All right, so we're going to start with the cos 90 plus alpha. We want to reduce that. When we reduce that, what does it reduce to? Anyone? Any volunteers? Okay, so for cos 90 plus alpha, it's going to become negative sine alpha. So that's the first reduction you're going to get a mark for, okay? Then the next one, remember, whenever you have anything greater than 360, you're going to subtract 360. Perfect. So what you end up with here is tan alpha because we've subtracted the 360. Let's deal with the denominators now. Sine 180 minus alpha, we're going to be... Yeah.
Ma'am, can I ask why are we minusing 360 if it is 360 and not like 361?
Okay, so if you look at this cost diagram, remember we always start at 360. 360 plus alpha means you've made a complete rotation, right? That's your 360. Then what have you gone and done? You've gone and added alpha again. So that's why we have to subtract the 360, okay, so that we make it an acute angle. Because remember, that's the purpose of reduction. You have to make it into an acute angle. 360 plus alpha is not an acute angle, okay? All right, so that's why we subtract 360, okay?
Got it, ma'am, thank you.
So Kenise, I'm not sure what you mean exactly. Will alpha always be an acute angle? When you reduce it, okay, it has to become an acute angle. So here, these values of alpha are arbitrary, okay? We don't know what they are, but when you reduce it, okay, this alpha here is acute. It's an acute angle, okay? Then let's deal with the denominators. 180 minus alpha, that is now sine.
I know.
Perfect. Then 180 plus alpha, that is?
Tan alpha.
Brilliant, thank you. All right, now at this point here, do you see anything that's common in the numerator and the denominator that we can cancel out?
Yes, ma'am.
Right, so the tan alpha and tan alpha will cancel out. You get a mark for all the reductions that you do. So the two tan alphas cancel out. Now here you have negative sine alpha divided by sine alpha. That cancels out. What you're left with at the top is negative 1. So this 3 is going to multiply the negative 1. So our final answer is negative 3 here. Okay. All right. So 5 marks for a question that looks like this. All right. Okay. Now, okay, so this was in your Siavula assignment. Okay, before we do this one, let's do this one here. Okay. So for number 2, if sine 72 degrees is equal to P, express the following in terms of P. Okay, so you have the first one, sine 252, tan 18, cos 108. Whenever they give you a question like this, okay, the first thing you have to do is solve the triangle first, okay? So we're going to take this sine 72 degrees is equal to P. We're going to plug it into a triangle like so, okay? Just give me a second. There's like a buzzing in the background. I'm not sure whose mic it is. Can you guys hear it, or is it just me?
I can't hear it, ma'am.
Okay, now it's stopped. Okay, cool.
Okay.
All right, thank you. Okay, now it sounds like someone's in the bathroom. Okay. Okay. Okay, so sine 72 equals P. Now, with this sine 72 being equal to P, we can write P as a fraction. It becomes P over 1. Okay, remember when you have your sine theta, this is equal to the opposite side over the adjacent side. Okay, so the opposite side here is P, the adjacent, or the, sorry, not adjacent, this is hypotenuse. Okay, so that's the hypotenuse. So the hypotenuse is equal to 1. The adjacent side, we don't know. This is what we need to find. The opposite side is equal to P. Okay, our theta, they've given to us as 72. Okay, now, first things first, we need to figure out what the adjacent side is. We're going to use Pythagoras Theorem, right? We know that the hypotenuse squared is equal to a squared plus b squared. You always have to write Pythagoras, and full like that. Don't write Pythag, you write Pythagoras. Okay, so the hypotenuse is 1. We're going to square that. Side A, we're going to use or take the opposite side, which is our P, and we're going to square that. Side B, that's your adjacent side. Okay, so yes, Matthew, go ahead. Your hand is raised.
Exam, ma'am.
Yes.
Would we have to do this at the beginning and then start answering A, B, and C?
Yes, I would
So would this
suggest.
count for more?
Yes, it definitely does count for marks.
Okay.
Okay. All right. So,
ma'am,
yes.
sorry. When we do this in the exam, do we have to state the formula hypotenuse is equal to a squared plus b squared, or can we go directly into substituting and then write Pythagoras?
So you can do the substituting and then write Pythagoras. Okay, so that's the important part.
Okay.
I was just
Thank you,
doing the hype squared so that people know what I'm substituting into. Okay. All right. So we want to solve for the adjacent side, okay, or the missing side. So balancing method, 1 minus p squared is equal to the adjacent side. Inverse operations, you're going to square root both sides. Okay, when you square root both sides, the adjacent side ends up being equal to 1 minus the square root of 1 minus p squared. That is what your adjacent side is now equal to. Okay, so we can go and plop this in there like that. The square root of 1 minus p squared. Okay, so you get a mark for showing that the adjacent side is square root of 1 minus p squared and your reason. So this could be 1 or 2 marks, okay, just for doing that. Now, sine 252. So the first question, sine 252 degrees. Using your cost diagram, which quadrant do you think this 252 is in, and how are we going to reduce that?
It is in quadrant 3, ma'am.
Perfect, right? So if it's in quadrant 3, that means it's 180 plus your theta. So what did they do to get 252? Right? They said 180 plus something. What is that something that they added to 252? I mean, to 180 to make it 252.
72, ma'am.
Brilliant, 72 here. Now, based on this, we can now reduce, okay? This reduces to what? Remember, if it's in the third quadrant, only tan is positive. So when you reduce it, it's going to end up as negative sine 72 degrees. Remember at the beginning, they told us that sine 72 degrees is equal to what? It's equal to p. So this is now negative p. There we go. You get a mark for the reduction and then a mark for plugging in your negative p. Remember the other mark came from solving for the adjacent side there. Okay, so part A is done. What's part B? Part B, we needed to solve tan 18 degrees. Now, remember we had solved our triangle. We had said this is 72. This is 1 minus a square root of 1 minus p squared. This is 1 and this is p. Okay, now what is this angle here? Okay, it's a right angle triangle. So what's this angle at the top here?
Let's see. That's 18. It is 18, ma'am.
Brilliant. That is 18 degrees. Okay. Now, based on this, what would tan 18 degrees be? Remember, we know that tan theta is equal to the opposite side over the adjacent, right? Opposite side. Now, this is in relation to 18 degrees. So what's the opposite side here? The opposite side is this one, okay? Okay.
Yes, ma'am.
So tan 18 degrees, your opposite side is the square root of 1 minus p squared. What's the adjacent side? The adjacent side is p. Okay. So we have expressed tan 18 degrees in terms of p. That would be our answer here. What's another way? Okay, we could have solved for this. It's a longer way. So maybe I shouldn't confuse you. Okay, let's leave it at that. Okay, but there are other ways of getting to this answer. Okay. Okay, so let's leave that one. Then C is cos 108. Okay, so we want to get cos 108 degrees. Where is it positioned on your quadrant?
Second quadrant.
Perfect. So if it's in the second quadrant, that means we're dealing with 180 minus theta. So what have they done here? What did they do? They said 180 minus what to give us 108?
72.
Brilliant, 72 degrees, right? So to reduce that, if it's in the second quadrant, only sine is positive in the second quadrant. That means when we reduce it, it becomes negative cos 72 degrees. Okay. It becomes negative because only sine is positive in the second quadrant. So we have negative cos 72 here. Now, let's go back to our triangle. Okay. Cos 72 degrees. Remember, cos theta is equal to what? Adjacent over your hypotenuse. Let's look at where our adjacent side is in relation to the 72. So the adjacent side is that, the square root of 1 minus p squared. So this becomes, don't forget the negative sign on the outside, okay? Square root of 1 minus p squared. Okay, remember, we're dividing by 1. You can choose to put the 1 in, but it's not necessary. So you don't have to show the division by 1 because anything divided by 1 is itself. Okay, so you can just leave your final answer as just that, negative, okay, the square root 1 minus p squared. Okay, any questions?
No, ma'am.
All right, okay. So someone was about to say something? No? Okay, let me go on to the third question. Now, this third question was from Siavula, right? Let's look at the question carefully. It says the following identity is undefined for some values of A, right? In the interval from negative 360 degrees to 360 degrees. What are these values of A, which will make the identity undefined, right? So you may get a question that looks like this. Now, remember, if they're looking for something that's undefined, which part of your identity do we look at? We look at the
Denominator.
Brilliant, denominator, okay? So if, let's say, so for this one, you're not going to look at both sides because there isn't a trig ratio on this side. But if there was a trig ratio on the other side and there was a denominator, okay, you would also have to look at that denominator on the other side of the equal sign. But for this one, since we only have 7 cos squared A, that's the only one we're going to make equal to 0. So the top, Okay, we're not going to deal with the top. We're just going to look at the denominator and make it equal to 0 and solve for that. Right, first things first, inverse operations or balancing method, divide both sides by 7. So you end up with cos squared A is equal to 0. Then next step, square root of 0, cos A is equal to 0. Right, now next step is you want to solve for A at this point. Solving for A, right? You're going to say inverse cos both sides, okay? A equals, whenever you take the inverse of cos on both sides, you're going to get two, okay? Two general solutions, right? So the first one is positive inverse cos 0. Your period is 360 degrees K. The second one is going to be negative inverse cos 0 plus 360 K. And remember, K is an integer. Okay, let's go ahead and solve further, right? Inverse cos, yes.
Can we just write plus minus?
You can just write plus minus. So the reason why I show it as two separate equations is sometimes it's different and you're going to have to divide certain things or whatever, but I always just do two separate ones. Yes, Roddy, your hand is raised.
Ma'am, I was wondering, do we need to show the inverse of cos times 0?
No, you don't have to show that. You don't have to show that. So some people jump straight to this part. So it's now 90 degrees plus 360 degrees. K, negative 90 plus 360 degrees. K. Okay, K is an integer, right? Okay. I remember I was saying I separate them so that people know that we have two general solutions here. Okay. Now, remember they were looking for the actual values of A. So we're not going to stop here because they were looking for the actual values of A. To find the actual values, we're now going to sub K equals 0 into both equations. So we'll sub into equation 1, then we'll sub into equation 2. So in the first one, okay, so this is 90 degrees plus 360. Where you see K, that's where you're going to plug your 0 in. So the first answer is 90 degrees. Then for the second one, same process. The difference is that, remember, you have negative 90 here plus 360 multiplied by 0. Negative 90. Are these two solutions within the range of negative 360 and positive 360 degrees? Do they fall within that range? They do. So we're going to keep both solutions. Now, let's go and sub K equals 1 into the first equation and the second equation. A equals 90 degrees plus 360 multiplied by 1. You're going to get 450 here. Is 450 within this range of negative 360 and 360?
No, ma'am.
No, so we can discard that. So Kenise is asking, must you show the subbing in or can you use the table method on your calculator? So I would say show the subbing in because we do want to see that you've subbed in and you haven't just plugged in stuff into your calculator. So show the subbing in just to be on the safe side because you're showing the marker that you know what you're doing. You're not just reading off answers from your calculator. Okay. Then for the second equation, negative 90 degrees plus 360 multiplied by 1. What answer are we going to get here? This is going to be 270 degrees. 270 degrees, is it within our range? Yes, it is. It is between negative 360 and 360. So we have 3 solutions so far. Yes, Safia, carry on, honey. Ask.
Ma'am, how do you know which values to sub in for K?
Okay, so K is an integer, right? So we keep subbing in, we always start off, okay, at K is equal to 0. K is equal to 0 will give you your first, usually your first two answers, right? Now, depending on your period, right, and this restriction they've given you, because they've told us that they're looking specifically for A values, which are between negative 360 and positive 360. Based on that, you keep going, okay, subbing in K values till you see that, okay, it's pointless me carrying on because whatever answer I'm getting is outside my range. So as you can see, like here, for this first one, we subbed in K is equal to 1, and that's the integer we're subbing in. We see that if we carry on subbing in, if we now try subbing K is equal to 2, the answers we're going to get are going to be outside the range. So there's no need to carry on and sub K is equal to 2. What you then do, you go and now try negative integers, which is what we're going to do here. Now we're going to say sub K is equal to negative 1. Again, you keep going till your answers are all outside the range. Okay, so let's do sub K equals negative 1 into the first equation. So A equals 90 degrees plus 360 degrees minus 1. Your answer you get here is negative 270. Now remember the restriction they gave us was negative 360 to 360. Is negative 270 in our range? Yes, it is. So we're going to take that answer. Now, if I sub K is equal to negative 1 into the second equation, let's see what happens. You're going to get negative 90 plus 360 multiplied by negative 1. We're going to get negative 450. Okay, so is there a point of me carrying on and trying to sub K is equal to negative 2? You could, if you did sub in K is equal to negative 2, you would see that the answers you get are outside your range. So now this negative 450, is it within this range, negative 360 to positive 360? It is not. Okay, so listing our final answers. A is, and I usually say start with the smallest and go to the largest. So negative 270 degrees. Then we had negative 90. Then we had positive 90 and up to 270. Okay. You won't get penalized if you don't put them in order, unless they've specifically said put them in ascending order or descending order. That's the only time you'll get penalized, but we just want to see all the solutions you finally decide on. Okay, so your final answer in the drop down of your Siavula, you would have selected that. All right.